Good day, everyone. So, we will discuss on how we can solve this particular problem as part of our Problem of the Day series. This problem came from the past board exam during April 2023. Here's the problem. The primary of a 3 to 1 step-up transformer is connected to a source, and the secondary is connected to a resistor R. The power dissipated by R in this situation is P. If R is connected directly to the source, it will dissipate a power of blank. For us to solve this problem, first we must go back to the concept of a transformer. So here it was stated that the primary of a 3 to 1. So 3 to 1, 3 to 1. This 3 to 1 in a transformer is basically our turns ratio. Turns ratio. So this 3 indicates the high tension side or high voltage side of the transformer. This one is the low tension or the low voltage side of a transformer. Since it was stated here that it is used for a step up, this high tension will simply become our secondary side or the load side, and this low tension will become our primary side or for the source to feed side. So turns ratio becomes 1 is to 3. Yeah. Let us denote some parameters. In the primary side, let us denote the primary voltage as Vp and the secondary as well as Vs. The turns ratio is simply the ratio of the primary turn to the secondary turn, which is also equals to the voltage of the primary divided by the voltage at the secondary. It was said that the secondary is connected to a resistor R. So I'm going to connect some resistor. The power dissipated by R is denoted by P. Simply put P here. So P. P is simply voltage secondary squared divided by R. This is the governing equation of the power dissipated by R connected across the secondary. Now we are required to solve for the power dissipated if this resistance or resistor R is connected directly to the primary voltage. Let us denote the primary power as Vp. It will have an equation voltage at the primary squared divided by the resistance R. We're going to need to have a relationship between the power dissipated in the primary, if R is connected directly to the primary, to the power dissipated by R when it is connected across the secondary. So earlier, we have this equation. The turn the turns at the primary is just 1. The turns at the secondary is 3, which is equal to Vp over Vs. Let us solve for Vp. Vp becomes Vs over 3. Let's substitute this equation in this one. So this will become Vs over 3 quantity squared over R. So simplifying, it will become Vs squared all over 9 divided by R, or Vs squared divided by 9R. As you can see, this part here is Vs squared over R is just simply P, right? So we're going to substitute P to that Vs squared over R. So Pp, or power dissipated by R primary, is equals to P over 9, or 1/9 of P. So you can see, therefore, power dissipated by R connected across directly in the primary will be 1/9 of the power dissipated by R connected across the secondary. Hence, this should be our final answer. I hope you gained something from our problem day today, and thank you everyone and have a good day.